All right, now we're going to talk about how we use the quadratic formula. We've derived it before, but now we're going to use it. We know an equation is a quadratic equation where the largest degree is 2. And for the quadratic formula is used to find two exact solutions, or zeros, or roots, or x-intercepts. And we always use it when we have the form ax squared plus bx plus c, and we all know that this is standard form. So in order to use quadratic formula, it's got to be in standard form. And our quadratic formula is this. And yes, you have to know it, you have to memorize it. Most of us have a little song we sing that goes with it, and your teachers will be passing that out to you. It's x equals the opposite of b plus or minus square root b squared minus 4ac all over 2a. We're going to know that so well by the time you take this quiz or test, it's not going to matter. Because this formula is what you need, and you do need to know how to, what it is, and you're going to have it memorized. Okay, the discriminant is the part underneath the radical. So this part of it is your discriminant. The discriminant helps us tell how many solutions there are. And we've sort of learned this already. We know under the radical, if it's positive, there's going to be 2 solutions. If it's 0, that's the only time we have 1 solution. And if it's negative, it says no solution, but it's no real solution. Because in Algebra 2, we're going to learn there's such things as imaginary solutions. But for now, if it's negative, there's no solution. So just by looking at this part that's under the radical, if you solve just that part, that's called the discriminant, we can know how many solutions we're going to have. You're either going to have 2, 1, or none. So for this first one, we're going to find the roots of this solution. And the first thing we have to do is to identify what A, B, and C are. My A is 3. Remember, B is in front of X, that's 10. My C is 8. Now I'm going to find the discriminant first. The discriminant is the part under the radical. That's the b squared minus 4ac. So I'm going to write that here. The discriminant is b squared minus 4ac. My b is 10, so this is 10 squared minus 4 times my a, which is 3, times my c, which is 8. I'm going to do the exponent first. 10 squared is 100. Minus 4 times 3 times 8. So that's 100 minus 4 times 3 is 12. 12 times 8 is 96. So 100 minus 96, and 100 minus 96 is 4. 4 is a positive number, which means we're going to have 2 real solutions. Okay, we know that right away. We're going to have 2 real solutions. And then when we go to plug this into the formula, I can just plug that in under my radical. I don't have to redo it again. So I'm going to do that now. I'm going to substitute these values for the quadratic formula. So it's x equals the opposite of b. So b is, let me move this down here so you can see what I'm doing. X equals the opposite of b. Get it in there. So that's the opposite of b, which is negative 10, plus or minus the square root. And you can substitute in these values for 10 squared minus 4ac, but I've already calculated 10 squared minus 4ac. That number is what goes under my radical. And then all of that over 2 times my a, which is 3. And it's really important that the whole thing go over this and not just the radical and not just the whole number. So I'm going to simplify from there. Now I'm glad I've got those numbers in there. I'm going to simplify it. Square root of 4 is 2, so this is the opposite of 10, plus or minus square root of 4, 2, over 6. And that's really 2 things. It's negative 10 plus 2 over 6, and it's negative 10 minus 2 over 6. Negative 10 plus 2 is negative 8 over 6, and that simplifies to negative 4 over 3. Negative 10 minus 2 is negative 12 over 6, which simplifies to negative 2. So my x is negative 4/3, and I have an x that's negative 2. And those are my 2 solutions to the quadratic. Okay, so we're going to try again. find A, B, and C. So my A is 1, my B is 2, my C is 1. My discriminant is the B squared minus 4AC. So my discriminant is going to be 2 squared minus 4 times my A, which is 1, times my C, which is 1. 2 squared is 4, minus 4 times 1 is 4, and 4 minus 4 is 0. Okay, and remember, if we have 0, that means we should only have one real solution. So I'm going to plug that into the rest of the formula. So I have x equals the opposite of b, -2, plus or minus the square root of b squared minus 4ac. I've already calculated that, that's 0, all over 2 times my a, which is 1. The square root of 0 is 0, so I have -2 plus or minus 0 over 2. -2 plus 0 over 2 is -2 over 2, which is -1. And if you take -2 minus 0, that's not going to change anything. It's still -2 over 2, which is -1. Those are the same answer. So I have one real solution, and that solution is that x equals -1. That's my only solution. And remember, when you have a 0 as your discriminant, you should only have one solution. So that's the answer. Okay, on the next one, I'm going to take a equals 4. Oops, I got a problem here because I have a constant over here. I have to, in order for it to be in standard form, it has to be set equal to 0. So I'm going to subtract 6 from both sides. This is really 4x squared minus 3x minus 6 equals 0. All I did is subtract 6 from both sides. Now my a is 4, my b is -3, and my c is -6. That changes the value of my c. So it's really important that you set it equal to 0 before you get started. For my discriminant is b squared minus 4ac. So my b is -3 squared minus 4 times my a, which is 4, times my c, which is -6. -3 squared is a positive 9. -4 times -4 is -16. -16 times -6 is a positive 96. And -9 and 96 is 105. 105 is a positive number, so I should have two real solutions. When I solve for x, I have the opposite of b. If b is -3, the opposite of that is +3 plus or minus the square root of my discriminant, the 105, all over 2 times my a value, which is 4. So that means I have 3 plus or minus the square root of 105, which is 10.25, all over my b, which is 8. So my two solutions are 3 plus 10.25 over 8, which is 1.66. And then I also have 3 minus 10.25 all over 8, and that's a -0.91. And those are my two real solutions. Remember, the plus and minus separate them out into two separate solutions. All right, number 3. Okay, it's set equal to 0, so I don't have to move anything around. My a is 3. My b is -7. That's the number in front of x. I don't have a c, so it's 0. Remember, whenever you don't have anything, it's 0. All right, my discriminant is b squared minus 4ac, so that's -7 squared minus 4 times 3 times 0, which is 49. 4 times 3 times 0, anything times 0 is 0, minus 0, which is 49. So that means I'm going to have, it's positive, so I'm going to have two real solutions. I'm going to plug that into my formula. So x is the opposite of b. b is -7. The opposite of that is +7, plus or minus the square root of this discriminant, which is 49, all over 2a. My a value is 3, so that's 2 times 3. So this is 7 plus or minus the square root of 49 is 7, all over 2 times 3 is 6. So my two answers are 7 plus 7 over 6 and 7 minus 7 over 6. 7 plus 7 is 14, which simplifies to 7/3. And 7 minus 7 is 0 over 6, which simplifies to 0. And those are my two solutions for x for that equation. Okay, we're going to try another one. Everything's set equal to 0. My a is -2, my b is -3, and my c is 2. My discriminant is b squared, so -3 squared, minus 4 times my a times my c. -3 squared is a positive 9. -4 times -2 is a positive 8, times 2 is 16, and 9 and 16 is 25. I'm going to plug that into my quadratic formula. X is the opposite of b. B is -3, the opposite of that is positive 3, plus or minus the square root of that discriminant, which is 25, all over 2 times a, which is -2. So this is 3 plus or minus the square root of 25 is 5, and 2 times -2 is -4. So my two solutions are 3 plus 5 divided by -4. 3 plus 5 divided by -4 is going to be 8 over -4, which is -2. That's one solution. And the other is going to be 3 minus 5 over -4. 3 minus 5 is -2. And -2 over -4 is a positive 1/2. That's my other solution. Hope you guys are getting the hang of this now. Okay, let's do 5 and 6. Okay, again, they're already set equal to 0. That's something to check. My a is 2. My b is -24. Yeah, let's put that down. And my c is 33. To get the discriminant, remember that's b squared minus 4ac. So my b is -24 squared minus 4 times my a, which is 2, times my c, which is 33. These are some pretty big numbers. -24 squared is 576. -4 times 2 is -8. -8 times 33 is a -264. And if I subtract those, I get 312. Crazy! But it's positive, so you know you're going to have two real solutions. To find those solutions, I have x equals the opposite of b. Since b is a -24, the opposite of that is positive 24, plus or minus the square root of my discriminant, which is 312, all over 2 times my a, which is 2. All right. The square root of 312 is 17.66, so this is 24 plus or minus 17.66, all over 2 times 2, which is 4. So my two solutions are 24 plus 17.66 over 4 and 24 minus 17.66 over 4. And if you add them and divide by 4, I get 10.42. That's one solution for x. And if I subtract them and divide by 4, I get 1.59. That's the second solution for x. Okay, just to make sure we've got it, let's do one more. I've got a equals 8, b equals -3, and c equals -7. For the discriminant, it's b squared minus 4ac. My b is -3, so I square that, minus 4 times my a, which is 8, times my c, which is -7. -3 squared is a positive 9. -4 times 8 is -32, and -32 times -7 is a positive 224. And 9 and 224 is 233. So that's my discriminant. It's positive, so that means I'm going to have two real solutions. To find those solutions, I'm going to plug them into my quadratic formula. X is the opposite of b. b is -3. The opposite of that is positive 3, plus or minus the square root of that discriminant, 233, all over 2 times my a value, which is 8. Square root of 233 is 15.26, so this is 3 plus or minus 15.26 all over 2 times 8, which is 16. My two solutions are going to be 3 plus 15.26 over 16 and 3 minus 15.26 all over 16. If I add and divide by 16, I get 1.14. And if I subtract and divide by 16, I get negative 0.77. It's a negative. Okay. Next thing, we want to find the base and the height of a triangle. In order to find the base and the height of the triangle, we sort of need to know, if they're telling us the area of this triangle is 50 centimeters squared, we got to know what the formula for the area of a triangle is. And if you'll remember from way back when, A is 1/2 times base times height. Okay, so I know that my total area has to equal half my base times my height. My total area is 50. Okay. So this is my area. This is my base. And that's my height. Okay, so it's 1/2. And then I have my base, which is x plus 3, times my height, which is x. I'm going to take half of all of that. Well, I don't like fractions. So before I get started, I'm going to multiply times 2 over 1 on this side and times 2 over 1 on this side to get rid of that fraction. So that'll cancel that out, so that all I have on this side is x plus 3 times x, and 2 times 50 is 100. Okay. Next thing I'm going to do is distribute. X times x is x squared. X times 3 is 3x. Or you could say x times x is x squared, 3 times x is 3x, either way, whichever way you want to distribute. And that equals 100. This is a quadratic because I have a degree of 2, which means I've got to, in order to use quadratic formula, I need to set it equal to 0. So I'm going to subtract 100 from both sides to set this equal to 0. This will give me 0 equals x squared plus 3x minus 100. Okay, my A is 1, my B is 3, and my C is negative 100. To get my discriminant, I'm going to take b squared minus 4ac, so that's a positive 3 squared minus 4 times my a, which is 1, times my c, which is negative 100. 3 squared is 9. Negative 4 times 1 is negative 4. Negative 4 times 100 is 400. So it's going to be plus 400, which is 409. That means I'm going to have two real solutions. I'm going to plug those in, the 409 into my formula to find x, into my quadratic formula. X is the opposite of b, opposite of 3, plus or minus the square root of my discriminant, which is 409, divided by 2 times my a, which is 1. The square root of 409 is 20.22, so this is negative 3 plus or minus 20.22 over 2. So that's going to be two solutions. The first one's going to be negative 3 plus 20.22 over 2. If I take negative 3 plus 20.22 over 2, I'm going to get 8.61. That's one possible solution. The other is negative 3 minus 20.22 over 2. And if I plug that in, I get negative 11.61 is a possible solution. The problem is we are measuring the side of a triangle, and I can't have a negative measurement of the side of a triangle, so that's an extraneous solution. I'm going to cross that one out. This is our one true solution for x. Remember, x equals that. So I'm going to come over here. X is 8.61. That's what we found out. My base, though, is x plus 3. So if you take x and add 3, that's going to be 11.61. So this is my height, and this is my base. And so that's using quadratic formula to find the height and base of a triangle. And that's all we've got for today. Thanks.